one which is covering how to do a new construction and how to go for a remedial work. All this stuff. Right? So that will be our motto. So before starting, just to give a very short introduction of all of those, just while you are working, what kind of the work you are doing. Very small introduction I want to understand so that we can enjoy it. Okay, so we'll start from yes. Yes, sir. You can come follow us. Here in the school, always better to be in the back. Always better to be in the back. Visibility becomes the good visibility on the back. Please. Okay. Yeah. Okay. Yeah. What's your name? Huh? All have taken breakfast, I hope so. Restoration. Here, all of you are from university or something. Anything else? Tarjah or it's like, yeah. We also want to know about. Sure, sir. Please come here. Please, please. Sir, please come. Sir, if you can introduce yourself, please come. Everybody will know.
Middle, we had a class also. That's the way.
Okay. Okay. So let's start. I have with us, we have our team also here with the actual lecture to take time. Okay, so I will not take much time to go to the program. So as we are discussing into, I will give a very short introduction so you all know about Cordially, but I will tell you a little bit on the one topic. So the whole idea of Cordially was established in 1959 and they are working, they started with a small company called Forest Marketing. And from there, the first product came out that is Rehabilitation, that is Fevicol, and everybody knows about it. Oh my God, with the years, the peptide has grown up and now become a company which is having an Indian multinational operating around 100% across the globe. Okay, and with an Indian counterpart, and as you all know about this brand, so I will not put much into that. We'll be majorly in the substance chemical dealing with the brand called Dr. Drop, facials, and all those which are into the CPs, into the industrial coding division. So these are the brands what we are talking about. Not only into the product, we are doing a quite a number of infrastructures, we quite a number of investments that is into the R&D sector. So that is one of the key elements. Because whenever we bring out with a product, there is a lot of fast process which is in the back end. You may be getting a product, but there is maybe a 6 month, 9 month journey for a product. Okay, until and unless it is got completely tested and certified, you not give you the product. So that is the way the R&D goes on. We have the R&D based in India as well as abroad. Similarly, this is a construction chemicals, product segments and others. I'm not, to be very frank, these 2 days we are not talking anything on Dr. Fixit as a product here. We are talking about the technology. We'll be talking about the how to way we are doing. Now coming to the midlife initiative of the Dr. Fixit Institute, let me give you a very brief on that. The whole idea of Dr. Fixit Institute was launched in the year 2002, so around 20 years back. The idea was that this is the industry, this is the area, the people who are working into this industry, their knowledge or their expertise into these waterproofing and repair were restrictedly limited. And it is not limited because of their experience with that time. But as the academics were never supported with these areas, so they were not knowing about the detailing of that. So that was the whole initiative when from this started. And in 2006, this was the company registered as a separate organization called Dr. Institute of Structural Protection and Sanitation. So this has then started as a quality, is a kind of knowledge dissemination hub, and then registered with Government of India as a partner institute, working with the skill development. Then we have also worked into the areas of the standard development. So that is one of the key elements. When you talk about, if you go back, some of you may be there, some of you working into that 2000 area. So there was no standards or codes of practices which is available. Now today, if I talk about something on a technology, until and unless I have something code, I cannot work it out. So that was one of the key areas or the deficiency in our Indian construction. So again, Dr. Fixit Institute taken a very lead role to get the standardization and the codes and practices also. We have done with the BIS, some of the codes and practices have been revised. I will be talking about some of the codes which are on the basement, weight areas and others where the Dr. Fixit Institute was very much part of that. had another one is two, that is called another one center, that is called the Doctor Specific Experience Center. Let me tell all of you, I don't know how many of you have visited. We have a Doctor Specific Experience Center where you can live demonstration of the system or solution as a model, and you can be there, you can see to it, feel it, and experience it. So Dr. Fixit Experience Center we have here in our Chennai itself, and that was the first of its kind which has been established in Chennai in Gopalapuram. That is like office with the basement and food is there. So I request all of you, I invite all of you to be there. So you in our mailing list, if there's anything, please come there and experience that. Okay, so Dr. Fixit Experience Center is this kind of the knowledge, and then we also have the Dr. Fixit Training Center. This is the experience center what I was talking about. This is the Chennai one. The Chennai one, which we are in Kochi, then just in Mumbai, and also right now we are in the north in Faridabad also. Okay. Now, Dr. Fixit Training Center, another initiative what we have started for around 2010 onwards, how to build up the expertise within the. So, telling something is showing something on a presentation doesn't go in until and unless, because this is an application. All of you believe, okay, I have to do a waterproofing or repair until and unless I do a right application. Nothing goes on. So we have created the Dr. Fixit Technology Center on the training center. And in the training center, we do the each and every aspect of that to the your hands-on practice. So in this program also we have kept half a day for the practical demonstration so that you can also experience it. We'll go through that. Then Dr. Fixit Institute, another thing we are doing the structural diagnosis, condition assessment of the structure. Because until if I have to go for a repair or strategy for any project, I have to first do a condition assessment of the structure. Dr. Fixit Institute is in a NABL accredited laboratory, which is a very highly sophisticated laboratory we have. And we are having all kinds of non-destructive, partial destructive equipment and the testing facilities available with us. To mention, I think you might be all knowing about the NDT facilities. There are rebound hammers, UTVs, or others. But other than that, Dr. Fixit, we are also having the concrete petrography, which is for a fire damage structure assessment. Also infrared thermography, CAPO, and a lot of different tests what we are doing the services across India also. Okay. So this is our Dr. Fixit advanced diagnosis center. We also do various kinds of short-term training programs from Dr. Fixit. And that's all about, I think I will not go too much into this. So this is briefly about what Fidelity is, what Dr. Fixit is, and what Dr. Fixit is. Okay. Now let's come to the subject matter. Okay. The first session will be discussing on how moisture, how the way water filters, how the structure gets deteriorated. That is, and eventually we will be focusing mainly on those structures which are RC structures. Okay, RC and the machinery structure. We are keeping limited right now to this structure, and I think most of you are dealing into that RC structure already. Okay, when I mean by RC, you already understand that the reinforced concrete structure. Right? So, let us understand as a concrete as a material. When it was started, anybody knows the truth? When concrete started first, anybody conclude? Any idea? Anybody from the party? They can also join. When we have started as a civilization introduced, we have started with our concrete as a material, building material. What do you mean by? Tell me. 1960. 1960. Before that, there was no concrete, right? What was the structure before that? Student saying, okay, yeah. Tutorial. Going from there. Concrete was used in the 1100 before the Christ. Concrete was used from that time, when in the 2200, 2000 years, now another 1000 years back, so around 3000 years back, the concrete was started using built by concrete. Okay. So that is the journey of the concrete, but in between there was no concrete. Okay. So the latest generation concrete again starts from the old later part of the 19th century. Okay, or maybe the 20th century is the starting point of that. Okay, in between we have used so many different materials. As I was talking about, we have used the lime and all other different kind of building materials. Right? Now try to understand what concrete speciality into that. Concrete is one of the. Why was the name concrete came? Anybody? Any idea? Why from the name concrete? Nobody. Modern now. Right? That's why you can say that we call it OPC, right? Ordinary Portland cement. The Portland is what? Portland is a place in UK. Okay, so when cement gets hydrated, gets solidified, it goes like a rock structure. And those rock structures which are prevalent in the Portland in UK, they are available in that. So that symbolizes that Portland name came from that. That's from the Portland came. Ordinary Portland cement. And cement means is bonding. It's the German word where from it comes out actual cement. Right? It's a bonding. Right? Now concrete means compact. It comes from a Latin word called concretus, which is mean compact. How the way you're compacting. The why it is named from that? Because we are making concrete. Concrete is what? Concrete is a heterogeneous. Am I right? Concrete is a heterogeneous. It is not like a homogeneous material. Like if you are using soil, if you are using rock, if you are using other materials, which are very homogeneous materials. But concrete is a mixture of 4-5 different ingredients. Right? So that is where how we can compact this whole material to make it a single mass. That's from the concrete. After water, this is the largest man-made material and the second consumed material across the globe. Okay, after water, the second largest consumed material by the human being by that of the globe. The most natural disaster-proof material. Again, I'm telling you, the most natural disaster-proof material that generally do not get covered. But we see a lot of stresses in the process. Okay, now how that stresses have come? If I look at the normal PPC, you will not say much distress. When from the you are bringing that iron into the material, the distress starts coming. Okay, so we will talk about that also. So this is all main part of the concrete. Now let us understand what is the distress. Distress means what? When any structure having its own bearing capacity, but the stress over it is beyond its bearing. So any structure when it experiences a stress more than its bearing capacity, we call the structure is a distress. Am I right? Okay. Now in concrete structure, how the distress manifests? How the distress manifests? Distress, how it is manifest? How it looks like? When you look into the concrete, how the distress is manifest? Material. This can be loading. This can be environment. Okay. This can be given by the human being. This can be during the deficiency in construction. Anything can be a stress, right? Can be stress even if of a settlement, soil settlement, everything can be a stress. The mass is not getting in the right position. Right? So that can be stress. So when the distress, there is a stress, the concrete shows this distress behavior or the distress in two ways. One is, as you have rightly mentioned, there is a crack, right? Okay, so that is why we always say when a concrete gets cracked, this is the stable. Okay, the concrete gets cracked means that is the stable concrete because it has releases its stress. It was when it is stressed, its energy coefficient was very high. When it releases its stress, disintegrate, crack, it is in a stable condition. But we always, when we go for a repair, we always look out for this. There is a crack, I have to fill that. Am I right? And here the mistakes start. There the actually the problem starts. We are again putting, and when we start putting that crack in some cementitious material, we are again create a stress inside that crack. And that's again the concrete gets cracked. So that is why after the crack filling, you get again the crack. because I have not taken out the stress from it. We have to take another stress. Okay, so this crack formation is called the disintegration of the mass. So disintegration, that is the one part. Second thing happens, which is the decomposition. Material decomposition. The inside matrix of the structures get decomposed. Okay. So slowly and slowly, there is, you must be knowing about the concrete. Concrete, there are different phases are there, right? Okay. In between concrete, as it is a heterogeneous material, to have its compressive strength, to have its all the performance, what is the most important in linking element? The most important linking element is that aggregate and the phase bonding. The interfacial between the aggregate and the phase. Right? If your interfacial part of the concrete and your phase and the aggregate, that come out, the whole structure. So that is the decomposition part. So decomposition happens the material part. Decomposition happens in the even if in the reinforcement part. Okay. So these two, when it happens, the concrete gets decomposed. Right. So that is the two parts. How the way you can see all different. The crack separates the integrity of the mass, and the detonation is the decomposition of the material matrix. This is the way of how it happens. Now, as a material, now taking into concrete again. Concrete is to look at it. What is the life cycle of a concrete? How is the life cycle of a concrete? Now I think that the material, right? We take it to the batching plant, we batch it, right? And then we transfer it, okay? And then transport it, then pour it at a position, and then the plastic mass is poured. After the plastic mass is poured, within a confinement, right? And then after some time it gets hardened. So from plastic it becomes solidified. Okay? And then we open it. The confinement gets opened up. Right? Now that concrete which has been solidified is open to the environment. Am I clear? And then it goes to the journey. And when this is so if you look at this whole journey, the concrete has this lifestyle. There are the 4 stages. What are the 4 stages? One is the formative stage, one is the service stage. Okay, one is the formative stage, one is the service stage. In the formative stage, concrete has again 3 stages. First stage is what? First stage is your fresh concrete. Okay, first stage is your fresh concrete. Fresh concrete means I have placed it is in a plastic state in the confinement. So that depends on as per your grade of concrete, depends on what kind of the areas you are going to place the concrete. What is your service requirement? Concrete can be 0 to 20 hours or sometimes maybe beyond all that. Right? Am I clear? So that is the first part of the first service. That is the fresh concrete. Second is the stripping of the former. That confinement opens up. Now it was under a confinement. Now I am opening up the confinement. Okay? Stripping of the former. That can be 1 day, 7 days, up to 7 days maximum. Third is your design compliance. Now at the 1 day it is not. When you are stripping of the former, that means the concrete is still not being a concrete we can design for, right? My TMS may be a 35. My TMS may be 35, so that means my concrete has to attain a strength of what? If you have a TMS. Design strength is your 35, then what is the TMS for it? Okay? Right? Normal as per 10262. Okay? So if you are going for a concrete of M35 grade, you have to go for attaining of 42.5, that is the minimum. If you go a major one, it can go up to 47 hours, right? So up to design compliance, your takes around 28. Where concrete gets is around 95 to 98% of the strength. Then concrete slowly gains its own strength. So that is the 3 stages. It is in the initial formative stage. Okay? The 4th stage is its damage limit acceptance. Where from it actually starts the damage. Okay, concrete doesn't get damage on a day one. Okay, there can be factors, stresses on the concrete, but that doesn't mean it damage on the very first until and unless it is very badly designed. Okay, it takes its own time. I'll show you some models also, how the way it has been discussed into that, and what is that by the curves also we'll talk about. Okay, so this happens now. All these 4 stages, the concrete goes through the different kinds of the stress, different kind of the stresses, different kind of the problems. So we'll discuss that part. So let's, before going that, just very simple one. Concrete is nothing but a two material. One is the phase, one is the aggregate pillars, and that binding together, right? As we have already discussed about that. So it's a pillar binder mixed together. Now, when hydration takes place, what happens? There is a paste piece comes out, right? We call it a calcium silicate hydrate gel. Am I right? Calcium silicate hydrate gel, which holds the whole material, right? Now, calcium silicate hydrate gel is a very strong link inside the concrete. So that is the matrix, that's the cross lamination, three-dimensional structure which holds the whole material. That is why concrete is having a compressive effect. It can take over the compression. But because of its two-dimensional network, it cannot take a tensile loading. It cannot take a tensile loading. That's why we put the tensile. That we all know about, right? Clear on that. But in this whole thing, when it comes up, there are another big link which is there. The big link is that is the calcium hydroxide formation. It is a very big link inside the concrete. So it doesn't have the string. It doesn't have the string. Okay, and that is the areas where concrete is actually big. But it has its own areas of application. It protects my stuff. It gives me a fascination. It gives me a fascination. Am I right? Okay. Plus, this whole reaction is an exothermic reaction, heat generation reaction. If we mix cement and water, there is a heat generation. There is a heat. Now, this heat formation, again, the first stress comes into it. The heat which is generated inside the concrete. Now, you have poured a mass. Suppose I am going to pour a concrete, so say around half a meter concrete, right? I pour. Right? You have poured. Now, normally, if we go into a layer by layer, but you have poured it, and there will be heat generation. And that heat generation will start creating the cracks inside it. It do not allow the liberation of it. Do not allow the liberation of the heat at the right time. So that is the first stage where from the system. I have not kept here, there is a leak liberation curvature also. The very initial, which is the aluminate phase reaction happens. Okay, where the heat generation is very instantaneous. And after that, there is a short down into your cooling filter. So that heat, when it comes down, you get the crack. You have to take care of that very right? So this is the thing. So that strong link actually holds the whole material and takes, as I told you, so heat is liberated, right? So going ahead, coming to the second part. Well, this is all on bone, but still we are just discussing to understand. Second problem where from the concrete comes. As it's a heterogeneous material, right? Mix it up. Okay, we have a different particle size, so we have added water into it. Now this water which is added inside the concrete to have its hydration to be done. How much water is actually required for it? And how much water we actually have? It governs by our again WC ratio, water cement ratio. Okay. Now, water cement ratio, there are two water cement ratio. One is called the water cement ratio for the reaction of the concrete. Water cement ratio, free water cement ratio, which is required for the concrete to have its plasticity to hold for a certain period. Am I right? Clear? If I only have a cement reaction has a water cement ratio, I will not get a plastic. Am I right? So, normally, the water which is added to concrete, this gives you a water for convenience. That means extra water, what we put inside the concrete, that is my extra water for the convenience, which actually helps me to do some of the other things. How to pour it, how to compact it, right? All those things. How much normal water is required for hydration? Any idea? How much water is required for hydration? I'm giving you that reaction we told about. How much cement and water is reacting, right? Okay, that is very simple one. Cement and water is getting reacted, right? How much water is required against 100 grams of cement because how much water? For its hydration to happen. Or in cube, 27 liters, what is the cube concentration? Suppose the cement containing in Huh? How much required? If suppose a it very simple. 150 kg bag of, let's take it very simple, not give it a too much action. 150 kg bag of cement, how much water can be added so that that cement can be get reacted and ultimately I get it. Should taste. What is the, how the way we check it? What is the check? What test we do? We check the consistency. What apparatus we use? Bucket, right? Bucket apparatus we use, we check the consistency. The consistency of the cement varies from 0.23 to 0.27 or 28 or 0.30, right? Depending on the cement compositions and other factors, right? So that is your water which is required for the hydration to take place. What is the extra water? That water for convenience, which actually helps me to get this work done, right? Placing, handling, compacting. Okay. So when you do, I'm requiring that first initial water for hydration. In cement, again I'm telling you, there is not an initial hydration. There is a continued hydration takes place, which is actually done by the oxides present inside the cement. You have magnesium oxide, calcium oxide, which is a continued hydration. So if you see the continued hydration, cement actually requires for its whole life cycle, it requires around 35% of the water. Okay? 35% of the water. So 0.35 is the critical water cement ratio. A concrete, you should add it. But when we add, the 0.35 is what? And 50 kg bag of cement is coming 17.5 kg, 100, 35 kg, 50 kg, 17.5 kg, right? Am I clear? Okay, now how much water we normally add? We add water maybe around 20 liters, 22 liters, because we have to do this very much, right? Now when you do into batching plan, now you all know about admixtures. I'm not going into too much into that, we can try to reduce it down. But that extra water, what we put, that remains inside the concrete, right? What is the problem? What's the problem starts out? Where from our whole discussion starts actually how water penetrates. Because concrete as a material, it doesn't allow water to penetrate. But how water gets penetrated? Water gets penetrated because this extra water which kept inside the concrete, that actually create a capillary that remains inside the concrete. With the time, it gets evaporated off. And there are the capillaries which is get created inside the concrete. Now again, capillary pore is not the problem. Capillary pore is not the problem. Capillary pore can be there. But if the capillaries are interconnected, the problem starts. So when your capillaries get interconnected, you get a continuous flow of water from the surface into it. And water then your leakage, seepage, dampness, all these things are. Right? So this is one of the most critical part of this, which we try to overcome. We have the mixtures, we have a lot of things which we try to overcome. Okay? We reduce down the water as best as can. Okay? Second part, we can also do it by the process of adding with your pozzolanic materials. The pozzolanic materials will also add your phase volume. Right? Your fly ash, GPSS, your metakaolin, your silica fumes and all others, this gives you an extra density phase form. Right? So your porosity formation chances get reduced down. Am I okay? Is it clear to understand? Okay. So that all those things we are trying to doing that. We are doing that. We are trying to make it up. Okay. Now, second problem. So this is one issue. Okay. Second issue. What happens next? Now, when you have added water in the concrete, after the cement is get hydrated, what is the next step happens? The next step happens, that is the shrinkage. Okay. Now, what happens? If you see the before hydration, this is the cement, that much is the water. Right? I'll give you a very simple example. Suppose it's the volume. You have added this much of cement and this much of water. Right? Now, after the hydration, you get the whole composition change. There is a hydration product. There is some bit of the cement which is not hydrated, that remains inside the concrete as an unhydrated cement. There is a water which is there inside, which is the gel water, okay, remains inside the concrete. And this is the capillary water which is there inside that. But the whole thing, if you look at the overall volume gets reduction. So there is a volume reduction technique, which is we normally call the shrinkage. And and that happens in the very initial plastic stage of the concrete. Am I right? Very initial plastic stage of the concrete. And these results in plastic shrinkage time on the surface, right? Am I clear? So this is the second part. Now we have done the concreting, we have mixed the craft, we have placed the material. Now after placing of the material, there will be crack. How to reduce it? Now again, when it will be cracked, the water will come. Right? Now try to understand, these are all I am talking in the formative stage. All I am saying cognitive, when we are making the structure, when we are making the concrete, the problems we have started introducing inside the concrete right from the day one. So a child is born with the deficiency. Okay? A child is born with the deficiency. We have to reduce it down. How much we can reduce it? What to do? The plastic shrinkage can be minimized by what? How? Yes? How we can reduce the plastic shrinkage?
Water cement ratio should be proper.
Water cement ratio can be reduced in the future. This is after the water cement ratio also. You can, this area definitely not reduce because there is fishing. Because cement has a volume, material is efficient. Am I right? Shrinkage is an intrinsic property of the cement. The answer is I have to do the curing. Am I right? Now, not only curing, start of that. When should I start that? That's very, very important. What was the initial hydration period? If I ask the people here that how much cement they have?
After 10 hours.
After 10 hours.
10 hours. The final setting time is 10 hours.
Final setting time is 10 hours. Now I will ask you. What do you mean by final setting? How you take the final setting?
The initial setting time will be 30 minutes. So that is the time. Final setting is
How you take the final setting? That's all we are at the site. I am not talking anything from the R&D perspective. We are talking at the site. We are all practical people. How will you check it at the site? We are telling about after final setting time, I have to start my curing. Now, how will you check the practical? In lab, I can do, right? In lab, I can do anything. What I can do is practical. Now, who does curing? Let's go to the company. Who does curing? At the site, who is up? United yourself. Actual. On. The nearmost level. Am I right?
Why are you doing after 10 hours? The target get it within the hour. When you say I can start this.
See, as far as told rightly, it is the final setting time. After that, I should start the curing. Am I right? And final setting time is checked by what? By a proctor penetrometer. Normally, am I right? Now there is height that there is no proctor penetrometer. Now the person who is going to do the curing, he doesn't know what is proctor penetrometer. He has never looked at it. He has never seen it all. How to operate the second part. He doesn't have a look at it. He doesn't know about that. Okay. The most junior, most particularly, normally we say that. Okay. We call it as do the curing, right? Okay. Now he let's start the curing. How do you? Now as an engineer, I understand what is my hardened concrete. I can understand. How do you understand? What is the simple guideline? This is why I am asking you. This is very critical at the site level. How I am instructing people. How I am instructing people. Because we make the concrete. We take the atmosphere from the RMC to make the concrete. It comes in a very sophisticated manner. The design is happening on a computer. Everything is pouring on the right. Transit mixer is coming with the rotation. I am making all the temperature factors, everything. And when I am pouring, my engineers are scattering. I am taking the quality cube, 6 cubes per batch. I am taking it to the lab, taking its strength, everything done. Concrete is poured. Now then, we all vanishes. There is only that soaking is standing there. Now you do what? Start. There you have to give him a right understanding. Put your hand. Simple understanding. Put your hand on the concrete. Give it up. Nothing should come on your hand. No impression, nothing should come on your hand. This is the stage. Start. Okay? Am I clear? Simple instruction for a layman to follow. Now, second question. How you? Now I have done the concreting. At 6 o'clock, my official hours end. I finish off my concreting, or maybe a little late hours, 8 o'clock, I finish the concreting. We all are going back to our home. We have a very straight day. Finish. No, sir, I have been into concrete for the last 14 years, so I know what the way it happens and it's a little slow. We have done the concreting. We all done that. Now the fellow is after 5, 6 hours, 10 hours, whatever. He will take it. He will do that. How he will?
There are a lot of methods of doing it. And as far as doing bond, we have to make it.
At
Printing
9
method, we have to do the printing method. And the third one is data technology, doing
If I ask you to use the curing component, you can add it cost delivered in the BOQ. They are not in the BOQ, so you can't use it because that's the cost involved. Am I right? Okay. Practical. At the night 2 o'clock, my 10 hours train ends. Who will make the bund? Nobody is there to make the bund. So all labor will resume work at 10 o'clock in the morning or 9 o'clock in the morning or 8 o'clock.
We have plan for the concrete.
Perfect. What is the easiest way? Now, if taking into account, you are doing. So in the 90% of the cases in the practical scenario, now that fellow has to continuously do that. He has to you are not there, nobody is there, he will speak to for certain time, then he will take the complete again back. Right, sir? It's practical, that's not very practical, okay? Very simple way. What is our purpose of curing? What is the purpose of curing? To avoid, not avoid hydration, to avoid the liberation of the water from the concrete. Am I right? If the concrete, that the water gets liberated out, then only the capillary formation will start, right? So we should not allow the water. That's why you pour water, right? So through the water cannot pass, right? Through the water, it doesn't allow the osmosis to happen, right? Same density cannot go. What you can? I can put a plastic sheet on the concrete, right? It will easily can protect my concrete from the initial plastic crack. Am I clear? So I'm telling you very simple things, sir. I'm not going too much into that. I'm telling you where we actually make some mistakes and where from the problem starts, and which we can do. Am I right? Okay. So that these are the scenarios what happens at the structure level. Plastic shrinkage is one factor. Second factor is called a plastic settlement crack. You know what it means by plastic settlement? Any idea on plastic settlement crack? You have any idea? Anybody heard of the word called plastic settlement crack? Yes, sir. Have you seen that any time the plastic settlement? What is the plastic shrinkage crack look like? It gets cracked, which doesn't have a much thick depth. Okay, it will be on the surface. Because the plastic shrinkage happens because when the air percolates over the concrete and your water starts evaporated, then your drying up comes in and that's the shrinkage comes in and that is also comes in. Otherwise, plastic shrinkage crack is not an issue. Only issue with the plastic shrinkage crack, it doesn't have a pattern. So if it becomes too much, then you have to do the again protection on the surface, something has to be done and then you can do it, right? But plastic settlement cracks is one of the critical factors. Now plastic settlement cracks happen when the concrete, I'm bringing the concrete from the transit mixer, right? Now we always try that I am doing the concreting at the say 20th floor. Say 20th floor I'm putting my concrete, I'm bringing my transit mixer, I put the hopper, then I have a boom pump, putting the concrete at the 20th floor level. Right? Now for this, I want a workable concrete at my 20th floor where I can pump it. Okay? So we always ask to this, get me high slump. Get me a high slump concrete, high workable concrete. Okay? So the concrete came with a slump of around say 170, 160, 150, right there. Okay. Now that concrete is poured. That concrete gets poured. Now at the position, you are pouring say 150 or 200 mm slab. I pour it. Now the plastic stage, concrete, when it's been poured, it has its own weight. Am I right? Concrete has its own weight. In a plastic stage, it will try settle down. Am I right? It will try settle down. Now, what are the factors into the what are the things will come, restrictions will come? You have the reinforcement bar. Sometimes you have the hair size aggregate, which are already there in the mass. Now the paste will try to settle down, and paste will try to settle down around your reinforcement to come down, right? Okay, and there is a obstacle in between, and because of that obstacle, the concrete will get a crack, and which crack can be depth up to your cover, up to your reinforcement. So it can become up to your reinforcement. Okay, because when the concrete settles out to your reinforcement, there is a gap creation, and because of that, there is a crack because you are getting an obstruction. Mass is settling, there is an obstruction, there is a stress, and it gets cracked. And that crack can be kept up to your cover shape. This is really, really dangerous. Am I right, sir? Okay, so this is called a plastic surgery, which we need to do. That is why we always say, if you have to pump the concrete, make it a pump consistency concrete. Don't go for a very high slump. A pump consistency, what is mean by a flowable concrete and a pump concrete? What is mean by a flowable concrete and a pump concrete? Pump means what? I have to pump the concrete. Huh? From below ground level to 20th floor, if I have to pump it, I require a very uniform consistency of the concrete at my 20th floor level. So my whole idea is that I have to make this concrete homogeneous. Okay, homogeneous. That is a first. If my concrete is not homogeneous proper, heterogeneous, there can be a segregation at that level. My slurry will come, aggregate will come later. So I require a homogeneous. What is required for me? I require a more viscous concrete. Not a high flow concrete, high viscous concrete. Why viscous concrete required? Again, when you are pumping it, there is an obstacle which is coming. You have a surface friction in the pump. Am I right? With the pump. So because of the surface friction, if your concrete is not homogeneous, not viscous, again it will segregate at the pump. Am I clear? So that is why we have to minimize that plasticity of the concrete should be at that concern. We should not give you a plastic settlement that can be right. So that is another part of that. We have to check it as doing the quality part. Okay? Yes.
Starting laying the concrete. The afternoon session. Slump of concrete.
So you have to adjust at the batching plant level. Suppose you are getting say that's a very good question. Now I am doing the concrete starting at a 4 o'clock. That's a large pool. Okay, maybe a 10,000 square meter pool I have. Whatever. So I have started at a 4 o'clock. The day temperature is high. So I will keep my concrete to come here. And I require a concrete slump at the pouring level, say very around 80, 90. Which can be compressed. Easily can be compressed. I keep for my distance. Now what distance platform it is coming. Okay, if it is coming from around 1 hour distance or maybe half an hour distance, or you have a captive batching plant at your site itself, then you need not require a very high slump at the batching plant, right? That depends on the quality. I'm just telling you, depending on the project. Now suppose you are bringing from the concrete RMC. Now RMC is around say 1 hour journey. There is a traffic, all the factors, you keep around 1.5 hours is the time limit. So my slump at site should be around 80, 90 at 1.5 hours time, from 0 to 1.5 hours. So then you keep the slump at around 130, 140, 150, whatever. Okay, so that is. Now, as the day will come, your temperature reduces down. Okay, now this reduction of the slump will reduce down. Now we can keep 100 there to get it at 70 here. Say, I am giving an example. So that changes can be done at batching plan. That is a batching plan. And that batching plan, they do that. They don't do it. It really can be controlled. Then again, if you are doing a hot weather concrete, you can do with ice and others. That are all possible. That is not an issue now. Okay. But problem happens if the plastic mass is very plastic and after the pouring also, to face this problem. This is affecting your durability. Your strength is becoming. Right? Your strength is I'll tell you another issue. When we do the checking of the concrete property, we only check is what? If my 28 days strength is coming to 37, 38, I'm happy. That concrete might be having all cracks, but still I have water strength. I'm happy with the strength. Concrete is not measured only by the strength. Concrete is measured by its performance. Okay, there are so many other properties of the concrete which we never check at a quality. Am I right? We never check it. So these are factors which actually problems are. Then grind shrinkage, I think need not to talk about. These are happens in the later stage of that. Right? The grind shrinkage slack those are. Now these deficiencies as I was talking about, it can be erroneous process of sequence of construction. It can be even the sometimes happen, other distances happen if I am departing out from the point. Now sometimes what happens, we are in the flow of the flow. The drawings are on one part, we are doing it. After some one time we are opening it up, we are seeing that we are design change that. We have to back to the same. Normally doesn't happen, but sometimes in project it happens. We are in the flow, we are doing the work. We have never gone back to our tender document. What is given there? Okay, sometimes we miss it out. Then non-permissible construction loading, poor selection of material, defects in the compound. Then air void, honeycomb, these factors. Air void is quite common. Okay, air void can be there because of the compaction. If the compaction is not rightly done, there can be air void. Improper curing we talked about. Drainage of the water. Lacking the drainage of the water, then detailing at the this is most important. How we are taking care of the joint part. Okay, wherever we are giving the joint, depending on the type of structure, then how we are ultimately treating that properly, or are we taking care of that? Are we giving the proper positioning of the joint areas, and how we are doing it? So these things, if you are not detailing, again the problem. So all these things are coming on the very initial stages. Now coming to the service stage. Is it clear on the formation stage? There are so many others. I just give very simple one. Coming to the formative stage. Now concrete is already stage 1 is covered. Now coming to the second part. It has already got a 20 days stage. Now in the formative service stage, it can have in the natural calamity problem. It can have in the other loading problem. So there can be a natural calamity. So this is beyond our control. Definitely we can't do that. You can do something for the earthquake, seismic designing and other parts you can do, but definitely other parts is not under control. Coming to the load distribution, there can be settlement, there can be overloading, there can be change in use of the service. The design of the structure was made for say around 500 footfall. Now today we are going for around 2000 footfall. The load distribution was not properly planned. Okay, sometimes people, I will give you some examples, a serious example. Changing use of the service structure, this is settlement, this is in the overloading part of it. Now, we have put all the use, most of the buildings you will see that this AC is put into that. Now, it's better to have it on the base. Support is on the base. People put it directly on the machinery wall. Okay, this kind of rack for putting the AC, they put it on a machinery support. On the top, it doesn't take. Next coming, now you can see this picture. This is the left hand side you have seen. I will show you the right hand side picture. Here, this whole thing has come. It's a building in Mumbai. So what has happened? It was earlier a balcony. It's a cantilever balcony, right? Cantilever. Okay. Now this person what has done? Family got increased. Has to make another room for his son. Son has got married, made that his room, converted into a room. Now after being the room, that up to that what was like, okay, that can be done. You can make it that much good. Now after making the room, I have followed the structure. This is cantilever structure. We have put all the loading at the corner. Almirah, things, everything on the corner. One fine morning, the whole structure. This is quite common. Quite common. Sometimes the battle. Okay. So this is what we do unplanned modification. Unplanned modification without taking into consideration of the structure, without consideration of the consultant or the structure consultant, we do the unplanned modification, which is beyond. Right? Maintenance is one of the critical factors. This is visible everywhere. And sometimes, plantations is always something good. I have been to so many buildings in Mumbai and other parts of India. There is a plant. People think, there's a lot of things there. I asked them, you have to cut it. I no. God is there. Plant means there is a God. Now you cannot remove God from there. Plant should be there. Am I right? Okay. So these kind of things were quite common. Other factors which are discussed, there is environmental factor, temperature, moisture, saline atmosphere, chemical spillage, your polluting part, oxygen, fluoride, all these pollution materials, carbon dioxide, these are all there in the environment, right? Now, what is temperature factor? I think this is very common. There is a differential temperature variation. If there is a differential temperature variation, we see the cracks on the surfaces of the roof, cracks on the surfaces of the wall, commonly visible, right? Okay, because of the day-night temperature variation, because of the expansion contraction take place. If you have not given the proper provision for a control joint, if you have not given a provision for an expansion contraction to happen, that will, right? Because, and that is very, very commonly visible problem. You can see this kind of cracks on the surface is very, very common. Okay? And that happens. Now, normally what happens, we built up the grid on the top. After doing the roof, we built up the finishing grid. And finishing grid, if suppose at 2,000, 3,000 square feet areas, we never do it just one together, all together, right? Okay? Never give a provision for a control joint. Now, temperature behavior will be there, temperature changes will be there. And now problem is, what is the problem? Now cracks can be there. Problem is, now these cracks are irregular. Now when you have to do something on a treatment, you have to open up the whole area and then you have to redo it. So this crack, treating this crack is very, very difficult. But if I put in a control joint, what is meant by control joint? Control joint is putting a weak points creation. Am I right? It's a weak point creation within the slab structure. If I create a weak point within the structure, my cracks will be on that line itself. Then it can be easily treated during your repair process. But when you are not provided, we have come out with that. And there is a lot of areas and you will get a force of water will be coming if it is the top slab. Right? Building surfaces got different kinds of problems. There is a dampness which are here, and rising dampness, all those things we see quite normally. In the last 2 years, 2-3 years before that, when Chennai faced a huge rainfall. Okay, you might have seen what was the problem. So we have got a lot of inquiries and the people have started because there was no provision was there. Okay, the water was continuously standing inside that structure. Now, reasons for these, as I discussed already, I am not going too much into this. One of the critical part is one is the wrong planning. Now, you see this. This photograph, I normally show it in any of the video of the training program because, making a box sajja is always good from an architectural point of view. But provision to be given for that, where should it? Now, tell me, this is a building, suppose, and which is having, say, what D plus 4, 5, whatever you say. How I should treat this to cleaning up? Once I had a discussion with one of the architects, one of the college, called Mahatma Gandhi Mission of Engineering College, it is in Navi Mumbai. The whole library, it was on the ground floor. The whole library, up to knee height, it was a full with water. More than lakhs of worth of books have been to be thrown up. Okay. In that building, all the windows shades were like this. Right? Wow. It looks very good. Architecture point of view. Fine. Can you tell me there is only a spout given? Come on. Now in this photograph, I could not find the spout, so I will ask all everybody to check it out. Where is the spout? Okay. But that spout, given a say 50 mm, 25 mm spout will be provided. After a few days, that will be closed. Right? Now tell me, how will you reach here and do the cleaning? I have made it. But there is no provision for the window. Now these areas, why will we provide window shades? To take out the water, right? I have made a Babylon. Good window garden, roof garden. Okay? So these kinds of things that we can do, where to provide. Where I have an accessibility, I can provide it, but then I have to do it. Typical delayed planning. Now this building, and this happens. Even if in the vertical also, you see we have made a G+1 building and we have provision for the 2+2+2 to keep the column open, right? The enforcement is open for quite long time. And those enforcement from there the water filter. We have done a fantastic water filter. Roof is beautifully done water filter. But water is getting penetrated from there. Okay, you can see this is again an expansion work, it is not that. You can see the condition. Okay. Inadequate detailing at the intersection joint. So we are all making windows, panels, aluminium frames, everything we are doing. Too good, everything is there. Making a simple sealant at the side. Water gets done. Similar thing, we have to reserve. Quite common, right? Interior we all decorate. When we come to this condition, then our opens up our mind. What to do? Okay. Now tell me where from there is a metallic frame, right? Now every metallic frame there is an intersection, right? Everywhere there is a window frame, there is a metallic frame inside and from there. So everywhere you require a proper sealing, right? Otherwise what will do? Normally that is provided. The seals are provided, things are provided. But sometimes what happens when you do it, it's not provided. And you have a lot of intersections in the frame. And if it is on a relaxed area, then you have so many provisions of the water can be. Now once the leakage starts or the dampness starts, it will be very difficult where from it is actually started. Okay. Now this manufactured, instrumented properly at the factory level. But when it comes to the execution at the site level, the mistakes happen. The mistakes happen at that. I'll show you an example of this is a typical basement. It's in it's a building in Goa. Okay, I've been to this building. Now this is having a parking. So this is a building and there's a parking and this is a retaining wall. Okay, and podium was there at the first floor and there is on the parking. And this is the retaining wall. Opposite side is the toilet. Now tell me how to do it. We have called as what happens in our situation. We do not have provision to go out. Because if you have to do something, you have to go out from externally, you can do it to do. They have not given any provision of water on the site. No, there is nothing required. Just fill it up. Okay, so it is not going underground. We are keeping on above the soil, so there is no question. But you have created a podium on that. And into that you have all plantations, you have regular movements, the rainwater is accumulating and that rainwater behind that there is the soil and that water is going down and that from there is so what to do? Even if very good, you will be doing the soil stabilization, nothing other than that. Soil will be get stabilized, water will continue. Grouting will there is no other way. You cannot do anything. There are other ways it can be done. But situation is that we do not take care from the initial. Okay. So this started coming and when this situation comes then again this starts. Parking in this can be to the hydrostatic pressure. Majorly in the basement areas and retaining structures, the problem of water leakage normally comes from the static hydrostatic pressure, right? Because the water table is one of the critical segments where from the water comes and in the retaining structure you are holding the water. So that's why these problems are quite common. There is a lot of water accumulated under your water tank. If you go to the buildings and you're under the water tank area, there is a lot of splash of water for normal. Okay, if you do not take care of that joints properly, things like that. Capillary action, rising dampness, the water which comes from the soil and that goes to the pin section and these kind of the rising dampness are quite common in basement areas which is shown in most of the buildings. The water is coming from the below. Okay, we have not taken a proper DPC. Normally we have to do proper DPC. If you have not done a proper DPC, whatever the base. Normally what happens, the people, if it is inside of their house, they will remove everything, they will put some tiles or maybe the stones, fixing, and one fine morning it will again come to the top. So you have not come to the cause part. You have not come to the cause part of it. That's from which is actually coming. Right? Another important critical area. The separation gap between your column and beams and the brick wall. Then at new construction, what is it?
Normally we do nowadays we are doing with
Filling pad. Okay.
Line
Compaction here, you tell me, sir. How do the compact of the concrete? Can you do the compact? If you want to do place the concrete here, normal people do, they will make a very big thing and try to put it inside, right? And with that towel only, you try to. Am I right? And this will be the weak point. This will be the always weak point, and it will be a critical point because you have this is masonry and the concrete. There will be again a ground modulus difference, right? Okay, there will be differential temperature variations, and they will move differently, and if you always there will be crack. If you feel anything, any material which is rigid, if you fill it up, there will be a crack. And tomorrow when you fill the concrete, you will get a crack at this side. And it is visible. If you see all the buildings, the parapet wall and the roof slab, there is a crack. And it is quite common everywhere. Same with columns and the brick wall. Right? They are properly treated right from the beginning. There are different ways. Absolutely. So you have to treat it like it is an area where we experience movement. Now, if this experience a movement, I have to allow that movement to happen. If I seal it with a solid material which doesn't allow movement, it will definitely crack. So I have to always give a provision for movement at that time. These locations require the provision for movement to be available. And you have to seal it, and but the provision has to be given because there will be definitely movement. And movement happens when it is a column and the brick wall, there is a movement happens also. Right? Because of this type of problems, this is typically at your floor area, starting area. Most of the buildings inside the houses, if you go, these kind of problems at the starting areas are quite common. Normally, it is seen at the near to your wet area, right? Where your bathrooms are there, those outside portions you can understand. Sometimes these problems are there in between the walls of the two rooms. How will you, when you suppose you are going for a remedial waterproofing, how will you understand where from the problem has started? Now, this can happen because of 3-4 reasons. If it is at the ground floor level, it can be happen because of the rising dam. Okay? Even if normal floor, because of the tile joints are open, the water which is you are mopping the floor, that water will penetrate and that goes up. Second reason. Third reason which I have just shown you. This is the reason water is coming from there, it's moving through the brick wall, through the ground, there's a gravity, and then there is a beam below, and then it's showing here. Now see, areas are different. One is at the top level, one is at the ground level, one is at the tile level. Now all looks the same. Now you are gone for a waterproof inside the house. Everything is there. Right? It can be because of any reason. And then if it is near to bathroom, there can be bathroom. Okay? So these kind of problems are quite visible inside the application. Even if during the application of the waterproofing, we make a mistake. The waterproofing materials are not something we can cover it. Okay, let me understand. When we discuss on that, we have to always understand one thing, that what is the limitations of the material. Second thing, how to application to be taken. Okay, now what is the mistake here? a mistake here. First of all, the membrane here shows active. These are all patchwork he is doing. How the way he is doing now, he is creating another problem here at the top. Then heating which is doing, I will tell you, bitumen membrane, the heating is a very controlled heating. I don't know how many of you have done the bitumen membrane. Bitumen membrane requires a very controlled heating. If you make it too high, it will melt, the whole material will melt. Now you can see that the person is doing too much melting. The material itself gets melted. Now this is happens even if you have a best quality material at your side, if you do not have a proper execution. Execution plays a very, very important role. Right? So water movement, I don't say much into this. Now these are all problems which is visible. Now underneath there is another problem. Now this water which is penetrating inside your structure, it is not only showing only void, dampness or anything on that. Now it is also creating a problem inside your content. Now coming to the part that is the decomposition. How it happens? First and foremost, if the water is penetrating inside your structure at the very initial stages and trying to come out, what will be lost from your structure? You will lose your lime out. The lime comes out of your content. That is what we normally call it the leaching problem. You might have seen the leaching problem. Okay. The leaching is what when the calcium hydroxide inside the concrete it comes out. At the very initial stages, we can see the white spots on the surface, the very initial stages. And that calcium hydroxide which comes out, which is actually a passivation material for my concrete to protect, I will lose my passivation from it. That is first thing. Okay, so that is the leaching of the cement paste, and if the cement paste leached out, you will get a lot of increased porosity inside the concrete, and then your concrete breakup increases. I will not talk much into the exchange reaction, which is more into the chemistry part of it, because just give you an example, in the cement, there are a lot of different metals. Naturally, which one is reacting with the water? That is the calcium, right? But being cement is a material which is taken from your limestone. The limestone composition wise, there can be magnesium, there can be sodium, there can be all other different other material, aluminum, all of them. If there is a magnesium material is there, okay, magnesium when it hydrates, there is an expansion technique. Okay, if there is an exchange reaction happen, the magnesium, calcium gets exchanged by magnesium, the concrete itself gets bulged out, and there is a crack formation. Concrete will get cracked. So that is another problem which reacts if that water goes and that unhydrated cement starts reacting. Then this problem. Okay. Third one is important. Now, when water goes in and there is a chemical factors or the environment pollution, the first problem starts in an urban atmosphere. In an urban atmosphere, what is the first problem to start? Because you have a vehicle, you have the industrial emission, all those things are there. And your environment, your air quality is not very good. You are having the carbon monoxide, carbon dioxide on the air, right? Am I clear? Okay. Now this carbon monoxide, carbon dioxide are present. Now we are in Chennai, which is a coastal city. Am I right? Now coastal city is always having a moisture. The relative humidity of any coastal city is always around 75 to 80%, right? Depending on the timing period, right? So with the relative humidity, which is more than 70-75%, and you are having an environment which is having a polluted environment, which is having carbon dioxide, carbon monoxide. Now these two when together comes to the concrete. The concrete, the first problem starts, that is the carbonation. That is called the carbonation. Water and carbon dioxide, these two react and form a carbonic acid, right? Okay. The carbonic acid hits your surface of the concrete. What is there? Cover concrete. Okay. Now what was protecting my cover concrete? It was lime. Am I right? Calcium hydroxide, what I told you, that is like passivation. Now calcium hydroxide, when it comes in contact with an acid, what will formation? It all scientific. There will be a salt formation. There will be a salt formation. Your lime will be get consumed by the acid, okay, and there will be a salt formation. Okay. So your alkalinity of the concrete on the covered part, which is actually protecting your structure, will get reduced. And that's the problem starts at the very initial stages of the process. And same problem starts at your basement level when you are using as a parking. So when your cars park, there will be a vehicular emission also. All your columns and everything that gets carbonated very fast. Now let me tell you, carbonation doesn't get. Oh, what we do normally? When we go into any structure, suppose after 25, 30 years, we are going to structure check. How the way we check the structure? Then what instrument we normally use? How the way we check the structure, that how is the condition of the structure? What is the instrument we use? Rebound hammer. Now rebound hammer we check. Everybody seen rebound hammer? Everybody has seen rebound hammer. So rebound hammer, if you put on the surface, now you will get a fantastic strength of it. The concrete is already done. So rebound hammer, if I am checking on a concrete, suppose there is a column at the basement areas or maybe open area, I check the strength. Okay, the concrete is of M30. I will get a good of strength of M30 to 35 strength. I'm happy. So I'm happy because why? Because my concrete is having strength. My checking is only strength. Okay, but that concrete is already carbonated. That concrete is carbonated. You are not checking at all. You are not checking. Now carbonation, what is the problem? Now you are already, I'll show you. What has happened? The carbonation, when it happens, slowly and slowly there is a carbonation texture. The whole cover concrete gets carbonated. Now the lime has gone. Now as the lime has gone, the next step there will be the corrosion. Because your protection has gone. Your passivation has gone. That lime has been consumed. Right? Now you will start, that corrosion will start very fast. Okay? And as the reinforcement corrosion will start, the concrete will get damaged. Am I right? Okay. So till the time you are seeing a crack on the surface, the concrete is already damaged. The concrete is already damaged. Knowing the factors that we are only visibility, we have only seen from the outside. We never go into the check of the concrete condition. Okay, so this is one of the dangerous problems. That is the biggest problem today. If you see overall, the national expense on the structure is more than billions of crores of rupees. Okay, only on this enforcement. And it is not an India problem, it's a global problem. Today on the Arctic. Globally, this corrosion related problem is too high. Very, very high. Because till the date we have started that enforcement, as an iron has taken an enforcement, this problem has started big. Okay? You cannot avoid it also. Quite as I said. So we have to understand the process, how the way it happens. The situation is this much. How do you check? How do you understand that there is the concrete is carbonated? Anybody? Because until and unless concrete is got carbonated, the carbonation doesn't show anything. Now why rebound hammer was showing higher strength? Because that salt formation, the calcium carbonate which forms, that deposit on the surface. Now when you check the rebound hammer, calcium carbonate is nothing but marble. Marble is a very hard material. Now all marbles are on the surface of the marble, right? Now when you are doing a rebound hammer, what is actually you are checking? You are checking the surface hardness. Rebound hammer actually gives you a surface hardness, the rebound. Okay, it gives you a right? But concrete is already there. Anybody? UVs are actually used in autonomous possibility UV process of the white. That gives you the wavelength. There is a UV wavelength which goes. Okay, that goes and that is the speed of it. How much time it takes lambda by this. How to check the carbonation? Any idea? You have taken a course, then what do you check? How do you check? It's not visible. What has happened? What has happened to the concrete? It was alkaline, now it has become acidic. Am I right? Clear on this? Go back to your school days of laboratory. What you used to do? Acid-base test, litmus, phenolphthalein. take out the core, put phenolphthalein on the top. Okay. If it is a pink color, the concrete is good. Okay. If it is white color, concrete has got. Now from the core, you will understand how much my depth has done. Now you have taken a core, right? You have taken a core. Now you put it on that. Now the some bit of the portion, the font size is showing you white. The last bit is showing you the pink. Now you can understand if my 40 mm is my depth. Okay. So 20 mm has got carbonated. Right? It will give you an immediate interest rate that is my problem. Now I have to immediately protect it. There's a lot of materials are there, how they will protect it, coating material, anti-carbonation, things are available, those are things are. So this is corrosion, how the corrosion happens, I'm not going. Now in the corrosion, again one thing I will tell you. You know, why we are talking to these things a little bit more. Because when we go into a repair, now this thing is visible in front of me, right? Now I have to do the surface check, right? Now I will understand superficial enforcement. Corrosion can happen because of two reasons. One is oxygen, one is because of the chloride. Okay. Now what is the difference? How do you understand that this corrosion has happened because of the oxygen and because of the visibility? As a civil engineer, our visible inference is very important. How do you understand what has happened? Is it happened because of the chloride or is it because of the oxygen? Both the cases it will be corroded. Enforcement will get corroded. When you open up the structure, you will get the enforcement. Right? Now, sometimes there will be no enforcement, vanish. Right? Only brown mark is there. You see that this is the kind of problem. Okay, sometimes you get that whole enforcement has got corroded. Sometimes you have the some pieces are there, some pieces are vanished. There is no continuity in the enforcement. Right? This happens like that. Now, in oxygen corrosion, your enforcement corrosion will be like this. Uniform corrosion. So if suppose you have a 20 mm dia enforcement, if the diameter is getting reduced, it will be uniformly get reduced across the section. Then it is an oxygen induced corrosion. Now in case of chloride induced corrosion, your enforcement will be looking like at one position it can be 20 mm, some position 5 mm, some position 10 mm, like that. It's because the chloride affects at a certain point. It is called a pitting corrosion. It affects the concrete at a certain point and from there the corrosion starts. And that area gets vanished. Okay. Other enforcements are there, but in between that section is left. So it is called a pitting corrosion. Then you have to treat that section from fluoride protection point of view, because your salt might be having chloride or maybe the environment might be having the chloride. Right? So your treatment will be different. Treatment will be different. Okay, sometimes when this situation happens, there is a spalling, na? What do we normally do? There is a spalling, concrete has come out from the roof. What do we normally do? Anybody as a waterproofer or anybody as a contractor, he will clean up the section. Then he will put some bonding material and then again put the concrete tank. Without checking the enforcement condition. Sometimes we check. We have checked how much is the enforcement balance. If there is any title given, we have to give the extra provision for the enforcement. But without understanding why that enforcement corruption has happened. Okay. And it can again start. Other problems in the concrete in a basement. Underground, where we are going to talk on underground structure, that is why this is fast on it. That is called as sulfate induced topic. Now, sulfates are always there at the ground. Okay, at the substructure soils, you will always get the sulfates. And sulfates are very common when you are at the coastal base because of the salinity of the sea. There is sulfate, right? Now, how sulfate reacts? Sulfate reacts with concrete, bulging up. And there will be immediately there will be a catch on the concrete. It has happened 7 years back in Mumbai. You know what was the problem? That we used to Mumbai and Chennai are both are coastal cities. Similar problems you can see here. Even here in Chennai, the problem can be much more. What was happening is that all the builders in Mumbai were using the municipality water for making the construction. Then in 2012-13, because Mumbai there was a scarcity of water. So they were municipality as DFI-SPR that will not supply you any water. You have to make your provision for the water. for your construction project. So what the builders has done, everybody has put the sump pump, okay, and they started taking the water, right? Now boring water. So boring water they have started sucking. Now what has happened after 2-3 years, all the Mumbai buildings, most of the buildings, specifically in the South Mumbai, where the vicinity of the sea is there, whenever they are going for after excavation, they are putting the retaining wall. Immediately after the casting, within another 1.5 months, the whole structure was getting. And that was a continuous process everywhere. Even. What was happening is that the water has been sucked from the soil. Am I right? They have taken the water to the bore. Now the ground level where the water was there, it has been sucked out. The sulfate was there. Now the sulfate concentration, when the water was there, the sulfate concentration was limited, low. Now you have taken out the water. The sulfate concentration has gone. Okay, the concentration of the sulfate at the soil has gone. Immediately after the construction is done, the sulfate gets in touch with the concrete, and they are getting that. The complete concrete was getting that, and it was came in the paper for the salt effect. It across the Mumbai it was a problem. Okay, and even in Chennai it can create a problem. Maybe some of the sites they are facing this kind of problem. So your water table is very good, right? Water table is very good. So when it reacts actually, there is a crack formation that you can see. A crack like that. There is a 5 to 6 times there is a volume increase. Some problems happens inside the concrete because of the reactive aggregates. I don't think in the south areas there are reactive aggregates, but if you go to the Himalayan range, you will get a lot of aggregates which are reactive. Okay, which are very silica rich aggregates are there in the Himalayan range because of that he has formed itself there. And where every building faces this problem because of the alkali aggregate reaction, the concrete gets reacted. Okay, which is an inherent problem. Okay. So let's come out of discuss whatever we have discussed till now. Now this is the damage process. Now these all damages happen inside the concrete because the pressure. Everything starts, without water I cannot make concrete, but water is the most dangerous element for us, and especially in case of the heart. Right? Now, if you see these two pictures, there are two damage. One is the two-stage process, one is the method. What is given here is the depth of corrosion versus the lifetime of the structure. Okay, lifetime of the structure. Now, this is the initiation period. As I told you, the concrete doesn't get deteriorated at the initial stage. The first stage is an initiation stage. This is the time period. What is called the initiation? The same thing you can see here, this is no damage. So this is the initiation stage. But here, damage is going to be started. This is the initiation part of started. Once it gets started, at one stage, immediately the growth of this damage is propagation is very high. Propagation is very high. If you see in the metal case, the growth of microcrack again goes up something, and from here it exponentially goes up. Now, what this graph shows us, the problem is until if we not take care of the concrete at the initial stage, or if we do not take care of the concrete at its initiation stage of the problem, at one stage of the time, it goes beyond your control. You can't do anything. You can't do anything. Whatever the best way you do, you can't do anything. So this is one of the critical time area where from it is beyond our engineering. So it is damage is so far. Then you have to take a decision. I have to done. Demolish that core structure. I have to open it. Maintenance is important with proper checking. Whatever be the structure, I have to maintain it with a proper checking. Why I have told you all this? Because as an engineer, as a part of the country, okay, civil engineering is one of the making the assets of the country, right? Now we have to understand the overall cost of it. Now we always say very micro. I am making my building, I am making a small area, I am doing this. But as a whole nationwide or as a all over, we are making ultimately an asset. We are all part of that. Civil engineers, we are making problem here. If I am not taking care of this, what is increasing? My cost is getting. If you move to my next slide, you will see the economic cycle of a building performance, which gets exponentially high. Now, if you can see here, if you time versus building performance, if I put it, and if my initial construction, this is my minimum performance level, and this is my performance level as a design performance level, right? Initial construction, we try to build up at this level, right? But if you have not taken care of the proper construction mechanism at the right time, what will happen? There will be a continuous maintenance demand will come in the structure. Okay? And every maintenance, there will be a cost. Am I right? Every maintenance, there will be a cost. So M1, M2, M3 cost. At one stage of the time where the performance will come in the halfway stage, I do a proper repair of it. Okay? Proper repair of it. I can do a retrofitting or I can do a rehabilitation. Right? Again, I am adding a cost of R1. Again, the concrete is going through a cycle. Right? So it's a man-made material, natural material. We go through a cycle. Now the point here is now this initiation if you are not taken into and we are doing just a superficial repair and continuously doing it, cost I am putting. And one stage of the time that decision points come, my structure needs to be demolished or what? What is my life of this structure has finished here? Am I right? Life of my structure is finished here. What I have added into the cost? I have added into the cost all the maintenance repairs and which is a continuous cost for me. Now what is the total LCC of a structure? Life cycle cost of the structure. These all costs added to the initial construction cost and which is a fixed cost. If I make a good structure, if I make a bad structure, my cost is same because my cost of my project is fixed. Am I right? If I am making a structure say 50 crores, it is always fixed. Whether in 50 crores I can say and make a good structure, I can make a very bad structure. But my cost is same. Okay. So if I can take care of these parts well at the very initial stages, taking into provision within that, so my fixed cost can be definitely reduced and my time cycle can be definitely, I can increase the durability of the structure. How I can enhance the structural durability, I can reduce down the LCC of my asset, overall asset. Okay, and I can create my national capital not drained out. My own capital, my national capital doesn't get drained. Suppose you are in this college, these premises are under your control. Now these buildings regularly require repairs which does not get sustained. How much cost you are paying? Think of it. So that is why the construction, the new construction has to be taken care from the right way. And that is why specification, designing, drawing, construction, execution, waterproofing protection, it's a complete part. It's a complete part. Waterproofing, if you think it's a subcontractor's job. Let me tell you, very frankly, waterproofing is taken always as a subcontractor. Okay, my building is there, I will call a waterproofer, he will do the job. What I will do, my only concern is that, okay, how much is the warranty? So 10 years warranty, I will keep you 1 or 2% or 25-10%, I will keep it as to me. And I am happy with that. Ultimately, end of the day, whether he has done a bad work or a good work, he has taken his cost and gone out. You are putting money, continuously putting money into it. Ultimately, ultimately. So, that's one of the first they come the how we should build up in a right structure, how we should. And good construction practices is a very, very important how we can build it. That gives you the load durability. The 456 Indian standard talks about durability. I think I don't know how many of you know the 456 is the code which talks about the post concrete structures and it talks about the durability. That is the Indian code for durability, right? So what it is told, let us understand as a designer, as a construction person, what is mean by durability. What is the fundamental? Durability doesn't mean how much is my life. Durability doesn't talk about only that. Durability talk about quality of structure, performance of the structure, service of the structure. What is my service requirement of my structure, and with anticipated exposure property. Now, if you can see the design, the definition, which can perform satisfactorily in its working environment. Now, I'm making the working environment in Chennai during its anticipated exposure condition of its services. Now, I build a structure. Suppose I take this building, we prepare this building. I take it into a designer point of view. I take it, this building to be last for around 70 years. Okay. Now, in 70 years, the environment condition, the situation here will not be the same. Now, this building may have been constructed in the year 1990s, 80s, whatever. Now, 1980s, the environmental problem or anticipated exposure issues, today 22, completely changed. Am I right? Completely changed. But do you feel that if we do not anticipate that this can be changed, I cannot call that structure to change. Structures can easily demolish within days. We are putting crores of money for a flat, for a building, but ultimately at the day, within 5, 6, 10 years, you will get a lot of damages happening because we are not taking care of the protection parameter in the right. So this is important. Let us all have to understand this. Why we are talking about it. So it is not that I have to do it. I am trying it that way. I have done it. It is overall how we can build it in the life. Okay. So let's. In the 4, 5, 6, one of the things, simple things I will just mention here, what things you can do. First thing is that you have to promote wherever you are putting a structure, always make sure that drainage is important. You should not allow the water to stagnate. That is the first part, very first part. If you are allow the water to stagnate at any position, see I am telling you, concrete doesn't allow the water to be at initial stage. Doesn't. If I make a structure and you put a bucket of water, okay, I make this slab, you put buckets of water, a single drop of water will not come. Am I right? But if you allow where there is a pool of water, you will get it. So first thing, very first thing, stagnation should not be there. So slope, drainage, that is a fundamental. That is a fundamental. Second is member profiles and the intersection where we cannot do a proper compaction like your beam column junction. So where you have a heavy reinforcement, intersection portion, where we cannot do a proper kind of a compaction. Make sure that your concrete is properly made and we are having a proper flowable concrete properly finishes that. The base volume should be there, you can cover. So that is another important easy flow of the concrete. Secondly, concrete vulnerable where it is vulnerable. If you are making any thin section, right, I have shown you one thing, that window shade, your staircase below, which is a very thin section. If I am making a thin section of my screeding, thin section of my concrete, which is get damaged very fast. You all know whether concrete that L by D ratio is very, very critical. If you do not provision of a proper thickness section, this is the problem. Second thing, if this concrete is under a hydrostatic pressure only from one side, now the structure is having the pressure from one side, definitely the concrete will be damaged. Okay, so under hydrostatic pressure from one side. Secondly, partially immersed section. The columns, my substructures, my foundation, which are in partially immersed section. Now some bits of the areas are coming in contact with each other, some bits of the areas are outside. So there is a continuous wet-dry cycle which happens on that structure. And if you might have seen in the bridges, on the river bridges, you might have seen the area, the columns of the piers areas, where actually the water touches, the up and down portion, that much section gets maximum damage. Because there is a continuous wet-dry cycle. The water goes up, goes down, goes up, goes down. Continuous. So that is a section which is very, very critical. Then corners and edges of it. Wherever you have the corners and edges, and you have a combination. Okay, transition area. Make sure where the building is gate is designed. That is another area you have the. Okay, that should be properly designed and modeled. Material wise, you should have a proper seasoned cement, and you should not use the cement which is beyond a certain storage. It should not be used. at this factor because again, these are all from code. Whatever I will be talking here, everything from the codal practices. Any cement which is more than 3 months old, its expected reduction in the strength is 20%. So if I am having a cement which is 6 months old, if I have fitted it, I should not use that cement for my structure. I should use that cement for any non-structural users fine. Still it can be. But if it is going a certain time, you should throw it out. You have to throw it out or you have to take a billing. Okay. Quality of the water, again an important factor. Okay. As per IS, what should be my pH is around 6.5 to 7 should be pH. 6.5, it should not go below 6.5. Okay. Then other factors is its turbidity, its hardness, its chloride and sulfate. How much is my ppm level? I should know that. Because the water which is going inside, if it is that not pure, that will damage it. Okay. Similarly, aggregates, sand and aggregates, they have given the limit how much it should be there into that. Even the chloride and the sulfate. Overall chloride, depending on the type of the solute usage of the structure. Suppose if the concrete is not containing any embedded metal, it's a PCC. Okay? So my permissible limit of the total acid soluble chloride as per IS is 3 kg per cubic meter. Okay? But when I am using a concrete with a containing metal and steam fluid at elevated temperature, my permitted limit is 0.4 kg per cubic meter. So I should know overall chloride content of the concrete and from its overall intermediate. Limit state serviceability, what is called? Again, important factor is the cover. How much cover I should give. Now, if I ask you how much cover should be given on a structure, on a concrete member, what should be given? Anybody?
Different column is different, beam is different, and
It depends on what? Thickness of what? Thickness of what? Thickness of bar.
it's all is the zone 1, zone 2, like that also that's
What is depends? What is the factor? What depends on? And we are right on that. We are just going to anything else?
It's a moisture content.
Anybody else? Good. Yes, little ahead. Covered is factor on what? It is on member or it is on something else. If I am making a suppose in building, okay, my column cover has to be more, beam cover has to be this. Is it like that or has to be same? Why? Why?
Moisture content.
The moisture content to the column is same, beam is also same. It's the same rule. Why I am making the beam is 25 and column is 40? Same, no. Same atmosphere, column is also there, beam is also there. So why beam is 25? That is your actual kg. Your kging that is on. But cover is not kg. Cover is beyond kg. I am talking about cover. I am talking about cover. Not talking about complete section. What? Here there is zone. Zone on what? You have rightly told. What is? The cover is never dependent on the member. Mind it. Cover is dependent on two factors. One first factor is that what exposure situation you are. What exposure situation, whether you are in substructure, you are in superstructure. Second, which environment atmospheric exposure you have. Then in IS there are 5 exposure situations. You might be knowing about mild, moderate, severe, very severe, extreme. There are 5 exposure conditions. So cover is purely dependent on one is exposure condition. Second one, fire safe. Second is the fire safe. Okay. If the building or the building what I am making is service requirement, that is the fire can generate, or it is industrial building, there can be a fire generation, you have to have it. Okay, so these are the two factors which governs if you are covered. And cover is the very, very important because that's the protection. That is giving you the protection. The cover is nothing better than that. It's only giving you protection. Because your whole strength is coming from the gauge. Up to the area you have the reinforcement. Okay. So this is as per IS table 5 and table 8, 16. If your exposure situation is this, Your minimum cement content, maximum pH ratio, minimum grade of concrete, minimum nominal cover is defined in a society. So suppose I am in Chennai. Chennai normally it goes between severe, very severe also. Okay? Your minimum nominal cover should be 45 mm. Minimum. 25 mm, no existence, nowhere in the code. It is 45 mm, depending, it is a column, beam, everything, it should be 45 mm. Okay? If you are going to substructures, it will increase. Because that will be extreme. You have to go beyond 50, 60, 70. Because superstructure is not, substructure environment condition is separate, superstructure environment condition is separate. Okay? That is the important factor. The cover is very, very important because that is, and based on the exposure condition, what should be your minimum cement factor? Minimum cement factor, right? Okay? And minimum grade of concrete. Everywhere. This is the IS question. I'm not talking anything else. IS guideline. The IS guideline.
Now we can do only 15 mm.
Your exposure, and that's an exposure. Your exposure. Because you are keeping it exposed. Okay? So if you are giving 15 mm, then try to understand. There will be, now suppose you are telling that's an internal. Say my first floor, second floor. You are putting the tiles on it. So water will penetrate to the tile. Right? Keep the tile. Now put the tile. Water will penetrate. Now you are not allowing any drainage into that. Okay, that is again water will penetrate. Within the 50 mm cover, that structure will start reinforcement. Okay, so whenever it is a horizontal structure, there is a first point, promote drainage. You should have a drainage system. Normally inside the floor, we always keep it dry. Fine, okay, but that can be changed. Okay. So drainage, and if it is a horizontal structure, there is always a chance that water will go. Water will, if the water goes in. Okay, suppose you have a bathroom, from there inside, from the tiles it goes in. And then it will, if the slab is nicely cut, what will happen? The water will move to the floor. And then it will go up to the wall. And that's what you have shown. Okay. Now, if suppose that water will have to move somewhere. If you do not allow any kind of evaporation to take place, what will happen? The next part of it will go under there. So, whenever there is water is stagnated or water is cannot go evaporated, it will go under there.
Last case, top floor will be there. Top floor. Here it is bottom floor is.
So again, suppose there is a kitchen. There is a moisture continuous. That is why you need an immediate reinforcement of body. Understood what I am not saying? Yes. No, it's exposure. It's exposure. That's the only thing. Nothing other than that. It's exposure. Where it is exposure. All is done. The windows are open. The windows are open. There are the internal moistures are there. People are standing. Now all we are here. Okay, we are all frustrated, right? Right? These are all ready. See, you have to understand the world. Now if it is there is nobody is there. And I am keeping this room completely. So there will be a continuous humidity accumulating. So keep your flat closed for quite a long time. What will happen? There is a dampness. Why? Because that moisture cannot go. That's why you always say we have to keep the window open, things to circulate, the thing. Right? Cover blocks should be used in the right. That should not be that block. The wet tank should not be used. I think that should be stop using. Okay, better to use with the proper cover block. Form out should be rightly done because your form out is the critical part. So that if it is not properly, then tight mix concrete. So I am giving you very simple things which we normally do it. Tight mix concrete, conventional. Now you can see here, do not look into the here this part of it. Okay. But thing is that now they are making a concrete gone on the surface itself. Now you can see what of the water you are putting inside it, the whole water is getting absorbed by the platform concrete. There is no plastic sheet, nothing there. We do the smaller work, patch work, things. We never look into it. Wherever we go, just mix it, put it. Okay. see, this is the situation. Suppose you open up your formwork and looks like this, concrete looks like this. What to do? Have you ever done a situation faced like this?
Yes.
Huh?
Yes. Frequently, yes.
What to do? It's like a beautician job, we go to the beauty parlors and we do some touch-ups and finish up. And now I'm looking good. This requires a proper grouting, or if the severe case, remove of the concrete. You have to remove all this. It requires proper grouting. Until and unless you grout that superficial thing. Okay. No, in our waterproofing, that is why we first thing, we check the hammer. We make a hammer test. Okay, what's the condition? Because anything if you are putting on the top, that will be on the proper side. Sound side. This one. No, this is showing that if you are having a reduction, if suppose your void, now this is all the void status, if your void gets increased, your compressive strain, modular of elasticity, textural strain reduces. So you have increased the void. Then major source of leakage, we have discussed already. If it is a construction joint, now see this is a typical separation gap, expansion joint, how we have to predict properly, that we have to also look into that. So finally, any asset maintenance, as we have finished off that, first understand the defects, defects and damages, what we have started, right? Then adopt the good construction practices to prevent the damages at the initial stage. Create a building envelope. Building envelope is called internationally how the way you are making a protection around it. You are creating an envelope surrounding the structure. So it actually defines how the waterproofing, how the protection will be built up. And when we talk about that, we'll talk about how the way we build an envelope. Envelope, what is the importance of the envelope? If suppose you take a normal envelope, what is the strength of the envelope? The material. Am I right? If suppose I have to say in the certificate, my own certificate, I will go for a cotton make or something like that, right? Am I right? Important documents I put it. So material is first part. But whereas the weakness of an envelope, wherever you are having the joint, where you have overlapping. So that is why envelope is very, very important. How the way we have to build up this envelope. Carrying out the proper diagnosis and condition assessment of the structure, and finally adopt the right strategy and methodology to protect and repair the structure. Okay, that is the way how we should build up any asset, how we should build up maintenance, and how we should repair the structure. So this is very, very fundamental because until and unless we do the right construction, nothing works. Let me tell you very frankly. Sometimes people think that whatever has happened, bring some waterproofing and do that. Waterproofing only works if you have a problem. So, good construction, option for the good construction or alternate for good construction is not working. Good construction. So thank you very much for the session. This was the session I think that we required a lot of interaction within us. We will take a break for 5 minutes and then we will come back for the construction. Thank you. proof course. Normally in a building we provide a dam proof course or a dam proof course behind below your floor level, or course at your all concrete and the national level, right? That is need to be provided. So simple way, what we have to do, because these problems arises because of these only problem arises, we have already discussed on that. So when you have to do the protection has to be done at this level and also in between the two bricks level. Now in our National Building Code, NBC guidelines, I don't know how many of you gone through that NBC guidelines. That is in NBC guideline, which is an Indian Bureau of Indian Standards publication that gives you the guideline how to provide a tap. Okay, what is the guideline given? The guideline given wherever you have the plan section, okay, you have to create a barrier, a separation layer, a vapor barrier over there, right? Okay, earlier days when you used to do that dam proof course, how we used to do that? In between two brick walls, we normally provide a rich concrete, right? Now what happens in the rich concrete? The rich concrete, if you are putting in between the two bricks, that's a good part, that water will not go through. But what is happening, as we have understood that the concrete, as you add more cement, making it more rich, okay, there will be formation of the cracks will be too high. And then water can easily penetrate. And again, concrete being heterogeneous, so water can penetrate. So what we require at first.
1 minute. Just go in front. Go front. Madam, I'll go in the front. Just occupy the front seat. Go. What do you people on that side? Go. Just go in the front. Mobile move again. Close the mobile. Close the mobile, keep it inside. Just for half an hour, 1 hour, we cannot able to keep ourselves control in the mobile. Important session is going on. Sir, please continue.
Sure. Good. So we have to provide an impervious layer which will not allow the water to go. Right? So normally how the way the application does, there should be a kind of an waterproofing layer should be provided. There are varieties of the materials available. The best material or the better material will be any material. Now we are doing on a subsoil application, right? Now subsoil application, there is a problem is, now any waterproofing material, first things important for a waterproofing material, that should be impervious. It should be impermeable, and at the same time the material itself should not degrade by its exposure. Okay, if I am giving a protection material and that material itself gets degraded, then there is no meaning of protection. So I have to use that material which do not get degraded by the process. So in a subsoil situation, okay, always preferable to go with a bituminous material. The bituminous material has a chemical resistance property and it doesn't get degraded. Okay. So if you only use a cementitious material a certain lifetime, and after that gets degraded, right? So you have to give a coatings kind of a cover with the waterproofing materials. And now you can see here the first is on the outer side. This is all the print area section. This is the excavation to the ground level. And this section, this, and then over the two brick levels, in between two bricks, in between the brick level, this has to be protected. And then it looks like from the top view, if you see, this is the, now from here, if you can see, no water can penetrate. Now this is an impervious membrane. Okay. Over it, when you are placing the bricks, there you have to provide on this coating to protect. You have to provide a concrete layer and then put your bricks on. Right? So this will give your, wherever the water which is coming from the down, that water is getting stopped over there. Okay, so it is not allowing that water to go, even if from the outside, the inside. Right? Okay. So it's a very simple one. I have to protect. Now, again, thing is that another important factor, whenever because it's a standalone building, I'm not taking into too much consideration, but sometimes what happens, you have to, when you go into a basement, there are a lot of different consideration has to be taken. So we'll talk about that. The water table, topography, other things, what will come into the picture. Is it clear? This very simple one. I'm not going too much into this. Now coming to the high-rise towers. Okay, in the high-rise towers, what you have other than your roofs, external walls, and areas, you have two, three things which is more. That is, you have a swimming pool. You may be having the water bodies. Okay, you having the sections which having the plantations, landscaping, car parking spaces, everything on the top. Because nowadays, every construction, the service requirement has gone down, right? So there are functional requirement which is there. There is a podium section, and below the podium you have the basement, right? Okay, and that basement which is there, it has its own different service requirement. Functionality of the basement. The basements can be used for different purposes. We'll come to that also. How the way the basement definition and how the way we have to predict. Now, again, this is superstructure and that is the substructure area. Basement is your substructure. This is the substructure area. This is your superstructure. Yeah. Now, how the movement of water takes place? As simple, if you are having a structure, now this is your base concrete. This is your can be raft anything. Then if you have the flooring, the problem is if your water which can go from the below, comes from the below, which is there below your concrete, and also the intersection. The important factor is that wherever you have an intersection, that is the weakest section. Okay, so that intersection can be the wall floor junction section. Then even in the retaining wall, you have your all the construction joints, right? Because you have casted that retaining wall in the layers, right? So every layer you have another intersection you have created, that is the construction joint. The construction joint is again another weak section. So whatever water which is accumulating from the top, it can leak. So if you see an overall, you have one level of water which is coming from the below. Okay, one water which is another source is which is at the floor joint level. Okay, another water which is coming at the construction joint level. Okay, so this is what the way the movement takes place in a baseline, right? Other than that, you also have problems with the soils, the contaminated soils, the soils which is there. Plus, there can be, as it is, as I told, mention you in a basement, which structure requires attention because where you have a one side, you have the hydrostatic pressure. Now, a basement having a one side has the hydrostatic pressure. It is the water which is there on the soil on the outer side. Inside, there is nothing into that. Okay, so that requires a protection. Then there can be an aggressive chemical, sulfates, all can be present inside the soil level. So we have to take care of that. Third problem happens if there is a water pressure, there is an upward pressure which can create on the structure. The whole structure can be a floating structure. If there is a continuous water coming in, there can be a floating structure which can be created. So your base will become difficult. Second, third problems happens depending on your soil. What kind of the soil it is actually standing. Okay, so suppose the soils which are there into our western south zone is mostly the black cotton soil, which is having the liquefaction factor is very high. Now, after the water goes in, that soil settles, soften. And if the soil softens, the material, the whole structure gets settled down. And when there will be settlement, again there will be a crack formation on the structure. Okay. So we have to take care of all those things very initially to understand where from what are the problems are there. Okay. So these are the problems what we normally see. I'm not going too much into that. Now, second thing is that what are the risk factors? Risk factors. The risk factors is hydrostatic pressure, level of the water table, contaminated soil, vicinity of the landscaping pipeline. Now, in an urban environment, it is now suppose in an area where you are constructing it, you have the rivers. Okay, urban area you have the pipeline which is going, the water pipeline which is going through your subsoil. If that bursts, water will come. Okay, if you do not take a provision, that water may come. Okay, so you have to understand what is the close vicinity of the area. Depending on that, then what is the usable of that basement areas? Then basement levels. What kind of the basement levels I'm going? Now, depending on I can go the first level, second level, third level. Then depending on that, what is the pressure which is coming, how much pressure is coming to me, and then other problems happens once it is constructed. How can I trace it out? Now suppose your water starts coming like this, it's very difficult to trace out where from the water is coming because you cannot reach to the positive side. Now that is why basement structure is the only way you can do. You can do the right way in the initial level. The water tightness or the designing is very, very important because once it is constructed, you cannot reach to the positive side of the structure. Okay, and your protection, whichever has to be given, because your soil, your water, everything was on the opposite side where you cannot reach at all. Anything if you do from inside, it is just a negative creation, negative pressure creation, which may or may not work. May or may not work. Okay, so that is why the initial designing construction plays a very important role in the basement. Now, basement waterproofing guidelines. Let us talk about the basement waterproofing guidelines. So, in the guidelines, we'll start with how we do the construction. Let us start with the how we do the construction. Normally, the construction takes a very simple way of understanding. We will not go too much into the civil part of it. You can have the straight footings, then you have the floor levels, you have the PCCs, then you have the mat foundations, right? And then if there is a piling, you have the piles over there, and then you are building up your footings, and then you are coming to the building. Okay. So this is simple way of the slab level, and we move on. The way the construction takes place. Okay. Now, when we take into the consideration, first things you have to understand that whether I am doing that area with a working space or without. What is me? Now suppose it's an open land, okay, and I am going for a building construction. I have enough space. Okay, I can excavate, I can have open space areas, and I can do that. Sometimes what happens, you have two buildings on both the sides, and you have to do your construction in between. Not have much working space. Okay, confined in space. So, while you have to design for a waterproofing, you have to first understand how much area I am going to take. Okay, so this is the first consideration you have to take in very initial, from the specification stage, whether I have enough working space or not. Okay, second thing, how I am going to construct, depending on the structure. It's not only building, whether I am going to do the structure, excavate fully, and then coming up. Okay, so that is your bottom up construction. I go down to the level of the base soil level, and then I am constructing. Right. Another way, if I do not have the proper soil may fall off, I am doing top-down construction. I am doing first level, stabilizing it, going level, stabilizing it. You might have seen in the metro construction, they are done by the level wise. Okay, it's a top-down construction. Okay, then you have to, again, your protection will be every stage you have to build up the protection. Because your soil has to be stabilized, you have to go one by one. Okay, so how the way the construction I am going to do, it plays another important role to select the right waterproofing practice. Okay, which waterproofing practices should I have? Okay. Next coming to is it the open cut excavation or is the box cut excavation? Okay, whether I am doing that soil piling, okay, contribute piling or what I am doing, or I am having the open space into it. Next is what kind of the foundation I have. If it is only footings, isolated footings, or I am going with a complete matting, if I have the piling on that, because if I have the pile heads, pile caps are there, then each and every pile heads and pile caps I have to take care. Okay, and if it is having a normal wall without that, then I can do it differently. Okay, so designing is very, very important at the specification level, because when I have to do the waterproofing, the waterproofer or whoever is going to do, he should know that at this stage what are the things I do. Okay, until and unless I define it properly, I cannot go for the waterproof. Right? The very initial stage onwards it has to be started. All on a sudden, I done the whole some bit of the construction. I thought that I require a waterproof. Then what happens? You have to compromise. You have to compromise. Okay, and then there is what? Okay. Type of retaining wall. what kind of the retaining wall you are going to. If it is a diaphragm wall, stand wall, contiguous pile wall, steel sheet pile. Sometimes we are using steel sheet pile wall. If it is a steel sheet pile walls, that cannot be, we cannot do the normal waterproofing. We have to do a different way. We have to build it up. So each and every stage, as before doing, you have to understand. Next, coming to the confined and unconfined. As I mentioned, if you are having a working space or not, and then if it is a working space there, then what kind of the working space I am getting, how much area I am getting, and then finally, and then in the confined area, I am doing a single side shuttering. I have already done a building. I am doing a short retaining wall, and I have the single side shuttering. I have beating the retaining wall. Some areas I am retaining wall. I am creating as a freestanding wall. Okay, freestanding wall. So I have the enough space to whatever. But here I cannot do, I have to do a single side. So this side I cannot reach at all. So I have to do waterproofing how the way I have to do it. So each and every consideration should be taken. Then in the wall, what is the type of the wall? Is it a precast wall, or I am going with a wall, casting situ wall? Then if it is a precast wall, then where the joints are coming, where it will be, because every joint is an area with it. Okay, that you have to consider it. So I'm just giving you the understanding why these are all consideration to be taken while you doing a basement waterproofing. It is not a very simple way just to give it and good. But every consideration as a person who is doing waterproofing has to consider. Okay. Now let us go with the basement waterproofing. Now here, whatever we are going to talk, again we will be talking from the codes. Again, codes and standards. Now there are two standards. One is by the BS, and that is another standard which is made by our Bureau of Indian Standard, right? So BS standard is the BS 8102, which is of 2009, which is called the Code of Practice for Protection of Below Ground Structures, which is the mother specification, and from there the Indian specification comes the IS 16471. Okay, and which has been written in 2014, and then again recasted in 2017. Okay, so this is the specification. Whatever we will be following with this. Whatever discussion we will be continuing right now against that. Okay. Anybody has done this course? Not much. Now, as per code, what are the waterproofing, basement waterproofing system? There are three types of basement waterproofing system. Okay, one system, first system is called the tanking protection. Okay, so this is barrier tanking protection, right? Barrier protection means, or tanking protection means, I am creating a barrier at the positive side of the structure where from the water is coming. So suppose this is your structure, I am creating a positive barrier here where from the water is actually. So I am creating a waterproofing barrier on the outer part of the structure, which is a positive side. Okay, either it can be floor, it can be vertical, right? This is called the barrier protection. So this is the types. Let me talk about the types. So one is called the type A. Please remember this number, the type A. Okay. Second one is called the type B, which is structurally integral protection. Structurally integral protection means I have to make the structure completely watertight. How I have to build the concrete properly. Secondly, wherever the concrete is having the joints, or wherever there are intersections are there, I have to take care of them so that those joints are properly. So this is an integral. So concrete should not allow the water to go. So that is the structural. That is called type B. Okay. Second system is third one is important when we have a drain protection. Now drain protection. What is important that how I am, whatever the water which is accumulating I am not allowing that water to touch your surface. I am draining it. Okay? Drain it out. So that is called a drain protection. So it can be done in different ways. Okay, so I have to allow a drainage on the outside of my structure. Wherever the water is accumulating, I have to take it out and throw it. Okay? So these are the three ways. One is type A, type B, type C. So these are the three systems, three waterproofing protection systems as per the code. Right? Now type A, what is the tank protection? Now type A, again, tanking can be done three ways. Now if I am having an open space, unconfined areas, I can do the barrier on the external side of it. Now this is your ramp, this is your retaining wall. I am doing the tanking on the opposite, on the external wall, barrier protection. Right here. So this is. Sometimes what happens, as I told you, I cannot go to the outside. Okay, I have already have the file. I cannot go outside. Then I have to create in between. Okay. Third one is nowhere I can go. I have to construct the whole thing, then I can build up internally. So it is called the external tanking, this is called the internal tanking, this is called the sandwich protection. Okay, in between of the way you have to build it up. Right? Now, depending on the structures, I have to do it what way we can do. We will show you how the things are there. Integral protection, water resistant structures to be built up. Wherever you are giving the joints, you are specifically at what level you are actually creating a joints into that. Okay, there you have to take the precaution. Similarly, at the areas where you are water is coming into that, you have to create that one. It's a pile wall and it is the internal wall. Again, you have to create a protection at this level. Okay, so this is called the structurally integral protection. Next one is your drainage protection. Now, drainage protection has to be provided either externally, you can do a perforated drainage, or you can build up within the structure. Whatever the water which is coming to the structure, we are taking that water to the drain, bring it to a sump pump, and throw it out from. Okay? So, we have to provide the provision for the drainage inside the structure, periphery of the structure. Okay, there is material called a cavity drain membranes are there. There are proper drainage are there. Perforated French drains are there. The different ways you can do the draining part. Okay. Now these are the three systems. There is another way you can build it up. You can build up the drainage at the below level. I will tell about that a little later because this happens in the problem that suppose you have already casted a basement, right? The floor has been casted. Now, all of a sudden, you see there is a water is oozing. From the floor level, the water is oozing. Okay, what to do? What to do? If I want to do something from the top also, tomorrow that material also comes in. Because there is a continuous pressure, na? Continuous pressure. So, in that case, you have to create a drainage below the flooring. Below the flooring, you have to raise the floor, make a drainage provision, and then again you have to raise the floor. So that is another way of the creating the drainage protection, right? This is the channel, how the way that this water is taken, and this is the water which is taken, and then all the water will be taken to a drainage channel and it will be taken out to a sump, and from there the water will be thrown out. Now, in the designing of the waterproofing, now these are the types I have discussed. Type A, type B, type C. Three types I have talked about. Now here the question is, what is mean by water table? What is mean by water table? Yes, sir.
What is the level of the water?
Level of the water. The level of the water is a variable.
Pressure.
Level of the water will not be a static. It will not be fixed or anything. It's not a static. It is always a dynamic. Right? Okay, so we have to take care of what? Which is the maximum height. Okay, maximum height. So variable water, the maximum height, what is that? Question comes in. What about the water which will come from the ground level? Now you have a rainwater, right? Rain will come. So the water which will on the top, that will also penetrate in the soil. Okay? Now the rainwater will hit where? Your retaining wall. Okay? Now where the water table is? Which is affecting your structure. So where the water table is? The water table as per course to be considered at the zero. So we make a designing first mistake. What we do, we take the water table what we get from the geological survey or maybe the hydrogeological survey, what we get at the ground level, we take that as the water level. That is the first mistake. Is the first mistake of the code says you should take always the GL as your water. Okay, so you require a protection accordingly. I'll show you how the weather protection is. So this is the first risk part of it we have to consider. So how your water table is. Then accordingly your type A, type B, type C's are come. Okay. Then coming your desk study. Desk study of the soil. Geological study, hydrogeological study, then soil, what kind of the contaminations are there. Some areas will get a very highly chemical contamination. You know, radons, methanes, this kind of material which are very, very deadly. This can, usually people are using sometimes the bitumen membranes under the soil, under the underground portion. The radons and methanes can easily dissolve out your bitumen. Okay, so you have to understand which kind of the materials I should go for. Okay, so this is again the topography of the surrounding ground. Now the ground where we are going to do. Now as a waterproofer, when I reach, let me tell you very frankly, when I reach at the level that when already the basement has been constructed or it has already been excavated and things have been on it. We do not know how was the topography of that. That may be the area where water is getting, all side water is coming and accumulated at there. It is a slope is towards this. So if it is slope is towards this, that area will be continuously getting water. Even if after the construction. Okay, so we should know as what is the topography, how the way is water is actually accumulated. Okay, then we have to accordingly build it up. Then the highest water table, as we have already talked about. Second one is occurrence of the parched water table. Now, what is meant by parched water table? Anybody? Parched water table. You know, if you go to the rocky structure, okay, in the Andhras and Telanganas, you will get there are the rocky structure, right? In between two rocks, there is a pocket where water stays. Okay, we go to the rock structure, depending on you. Your water table may be around 70-80 meters down, but in between two rocks, there is a water, and that water it comes out. Now, I have not considered anything because water table is very low, so there is no requirement of any water. You have constructed that. That water comes. That is one thing. Second thing comes out, which past water table, as I told you in the urban areas. If you have a water pipe and that passed, or the joint opens, the whole water will be surrounding your buildings. It is already coming. How will you take care? You have not considered anything. This is another risk factor. Okay. So these are the factors which always comes in. Okay, any missing ground information that also to be. So this is the first case studies to be done to understand that. And definitely when somebody is doing a construction, these are the things always come. It is not that I am doing something new, it is always the geology studies, everything. Okay, but you know what happens? While we consider the waterproofing part of it, we never use it because we know that this can be done anyway. Okay, we have to take care of this. Then risk assessment also has to be taken care of for the climate change, trees, surface, and all those things, external drainage that are proposed, and all these things has to be taken care of. So, coming to the selection. Now, we have talked about 3 types of basement waterproofing. Okay. Now, what kind of the basement waterproofing we have to consider? The selections, we have to understand the classification. Water table classification. If suppose your basement is this and your water table is below your table according to the geology survey, then this basement can be taken as a simple consideration. This is a low water table basement. Okay? Low water table basement. Okay? So risk of water penetration here is low because here chances of the water is coming up, but there is a chances of water which can come from the top and which can penetrate at your retaining level. Okay, so that's why I was telling you when the real level, ground level water which comes, it will go and slowly comes to this level, but in its course it will affect your retaining walls. Okay, so that is why this kind of basement, if you go by the foundation, in your foundations and areas, the risk of water penetration, though it is low, but your vertical section, the risk of water penetration is variable. Okay. It is not low. It is variable, right? Depending on what kind of the raining coming, what kind of the situation. But when it is water table is above and your basement is low, so this is a completely wet basement, right? Here your basement is below water table, then your both the sections, your boundary section, floor section, horizontal and the vertical, both the section risk of water penetration is high. So there are three risk factors. One is low, variable, and high. And what was the type of waterproofing? Type A, Type B, Type C. Type A was barrier tanking protection. Type B was integral. Type C was drain protection. Okay, clear? Second consideration. So that based on that, the table says this is your risk associated low to high, water table classification, low, variable, high, and you have the three types of the waterproofing system. So which to be used if you are having a low risk areas with the water table and your water table classification is low, you can do type A or type B or type C or type C. Okay? Any of the three is, as your risk is going up high, your water table classification is high. Here you have to go for a combination of the systems. Okay, so that is why code always says the use combined protection. Use combined protection. So you cannot do only one, say only structurally integral protection I have taken. No. Code always says you have to go for a combined protection. Either you have to do the barrier as well as integral protection. Barrier, drain with integral. So always there is a combined protection always to be there. Because when I am mitigating with the risk, I have to always take care of the safety part. If one fails, another should be there. Because I cannot reach to this surface after the construction. See, try to understand why I am telling you, because this is one of the important area basement we always consider, because this is once you have done, you cannot reach that level again to do the work. So that is why here the risk and your system should be defined and designed right from the beginning in such a way that it has been properly done. This is from the specification. Okay. Here. Now the second consideration. This was on the water table consideration. Second consideration is how the way I am going to use the. Okay. Now that tells you there are three types of basement. One is the grade 1 basement, grade 2 basement, grade 3 basement. Grade 1 basement means it's a basic utility. Basic utility means it's only a parking area. Okay. The consideration what it has been given that there can be some seepage and damp areas are tolerable. Okay, because there will not be people will not be stand there, only the parking will be there. So some seepage and damp areas are tolerable. Okay. When it is a better utility when the areas like underground car storage areas, workshops, electrical plant rooms, there they are told no water penetration and ventilation should be required. Okay. But when it is a grade 3 and habitable, like there is office spaces, commercial spaces, restaurants and all those, they are there's a single drop of penetration, nothing dampness, because you have to run your AC system, humidification system has to be run. Okay, so I have to build up the waterproofing in such a way, so I have to go for a much more robust system. Okay, much more robust system. Okay, so these all factors. One is technical, one is protection, and third one is very important. That is how much is the cost. Okay, so that is why there is a provision that you have to understand that how much I can go. If I tell everything to be done and we absolutely can't do, that's too much costly. Too much costly. Your projects will not allow you to do that much of work. So that is why from the beginning you have to take consideration that what I am doing to consider, what construction I am going to do, what service I am looking from that basement area. So accordingly, I have to make my system ready. Okay. So this is the selection. So the selection based on that, depending on the situations. Now they have told again for the basement grade usage, again protection measures can be type A, type C, grade 2, and here it should be a combination of it. Okay. Combination of the. So these two combination taken by when you are looking into these two combinations, the code finally says that need is combined protection. Okay, need is combined protection. So how the way the combined protection works, what the systems comes in, how the systems to be done, what systems to follow, why to follow. We'll be discussing that. We'll take a break because we have to go for a lunch. Okay. Without food, nothing goes in the right. So we'll take a break. We'll go for lunch. Once we come back, we'll discuss in detail. We'll talk about a lot of materials. We'll show you some of the materials, videos, and all those so that you get a lot of understanding on that. Okay? Sure.
Something 1942.